Janardhan Rao, working in the Institute of Aeronautical Engineering College. Uh, my subject is operating systems, and today topic is evaluation of operating systems. So, earlier days, earlier days also there was operating system. That earlier days, our hardware, my microprocessor is 8080. It started evaluation from that onwards. The operating systems were first developed in the late years 1950s to manage tape storage. Earlier days that punch cards and tape storage it was available. So later on, as we had semiconductor memories, that is advancement of this system technology. The General Motors Research Lab implemented the first OS in the early 1950s for the IBM 701. In the mid 1960s, operating system started to use disks. In the 1960s, the first version of the Unix OS was developed. The first OS built by Microsoft was DOS. The DOS stands for Disk Operating System. It was built in 1981, purchasing the 86 DOS software from this CTL company. The first day popular OS Windows first came to existence in 1985 when a GA was created and paired with MS-DOS. So in this respect, I'm going to emphasize what is this GA. GA means graphical user interface. The types of operating system. An operating system performs all the basic tasks like managing files, processes, and memory. The operating system acts as a manager of all resources, that is, resource manager. Thus, the operating system becomes the interface between the user and the machine. So, as we are looking from the beginning, the operating system is the interface between the user and hardware. So, types of operating systems, some widely used operating systems are as below. Earlier days, before this, starting one is simple batch systems. Batch systems were there during the punch cards and tape cards, tapes. In this type of system, there is no direct interaction between the user and the computer. User and computer, there is no interface. Where is supposed to be, operating system supposed to be, but in those days, no operating system. That punch card system was there. The user has to submit a job or punch card. Punch cards are written cards or tapes, punching cards. The computer operator, then the computer operator places a batch of several jobs on the same input device. Jobs are batched together by type of languages and requirements. Then special program, the monitor manages the execution of each program in batch. The monitor is always in the main memory and available for execution. So as we have seen in this one, in those days, we used to make the batches, batch-wise. Operating system is nothing but a monitor. Monitor is a program in the batch processing systems. Okay, so job 1, job 2, job 3, M jobs will be similar jobs. So that monitor will monitor and get executed by CPU. In those days, the CPU maybe it is 8080 like this. So in earlier days, we used to use the processes like this one. Monitor is a program which is a main program as it acts as like an operating system. There is no operating system. Monitor is this program. That program only allocates or takes these several jobs and they process in the microprocessor. So simple batch system. This is CPU, and these are jobs. Several jobs are there, job 1, job 2, job 3, and this is the operating system. And this will only monitor. Monitor is a program which sequence these jobs and it will go to your CPU, and CPU will execute these programs. So monitor is the main program in the olden days of simple batch system. Advantage of the batch systems is it is very difficult to guess or know the time required for each job because it takes a lot of time. Processors of the batch systems know how long the job would be in the queue. Multiple users can share the batch systems. The ideal time for the batch system is very days. It is easy to manage large work repeatedly in batch systems. Suppose at disadvantages because since the jobs are in the queue, so first job is under execution. The second job has to be in the queue for a longer time. That is called starvation. Batch processing suffers from starvation. If there are 5 jobs, J1, J2, J3, J4, and J5 present in the batch, if the execution time of J1 is very high, then other jobs will never get time to execute it because they keep on waiting the job. They will have to wait for a very high time, hence the other process gets starved. That is starving. Not interactive. Batch processing is not suitable for the jobs which are dependent on in the user's input. If a job requires the input of 2 numbers from the console, then it will never be going to be get in the batch processing scenario since the user is not present at the time of execution. That is the disadvantage of the batch systems. The computer operator should be well known with batch systems. Batch systems are hard to debug. It is sometimes costly. The other jobs have to wait for a longer duration. So, example of batch processing systems, payroll systems, bank statements, etc. Similar jobs will be executed. So latest the version is multi-programming batch systems. In the multi-programming batch systems, what is happening? Simple example, our OS, you can do any job. You can minimize one job and we go for other jobs. That is the only simple difference between the batch systems and multi-program. In this operating system, fix up and begins to execute one of the jobs from memory. Once the job needs an IO operation, then the operating system switches to another job till input coming for the first job. So jobs in the memory are always less than the number of jobs on the disk job pool. So if several jobs are ready to run at the same time, then the system chooses which one to run through the process. That is CPU scheduling. As we discussed about what is CPU scheduling, CPU scheduling is a program which is ever in the OS, which controls, which monitors, which regularize which job has to be sent to the CPU for execution. So that is a program that it is available in the multi-programming OS, you can say. So our latest, what are the OS are running? They are based on the multi-programming batch systems. So multi-programming, if you look at this one, P1 is one process 1, process 2, process 3, J1, J2, J3. So this is multi-processing. So the instruction nothing but a job. So the OS will distribute the jobs as per the requirement, as per the availability, which job should be sent to which processor. That will be done simultaneously. This is multi-processing or multi-processing and multi-programming. So multi-programming batch systems, basically batch system only. Multi-programming is extension of the batch processing, where the CPU is kept always busy. Which process needs 2 types of system time, CPU time and IO time. So we already seen what is CPU time, what is IO time. So whatever the job is sent to CPU, how much time the CPU takes to execute that instruction, that is called CPU time. So IO time means the requirement of inputs from the whenever the input required for that job. So how much time it takes to spending time with the IO devices. That is time of input time, IO time. In multi-programming environment, for this time of the process does it IO, the CPU can start the execution of the other process. Suppose one job has come and it is waiting for the some input is required for the execution. So it will kept in the stack and CPU will start another job. It won't wait till the input comes for the first job itself what is executing. So it will switch on to another process, another execution. CPU can start the execution of the other processes. Therefore, multi-programming improves the efficiency of the system. In multi-processing, parallel computing is achieved. There are more than one processor present in the system. As we see in the latest computers are multi-processing because i3, i5, i7. It means that instead of one single processor, as we used it in earlier days, instead of one place, we use i3. It means instead of one microprocessor, then you can have 3 microprocessors, 3 ALUs. 3 ALUs will be there. So in that case, whatever the program is being executed by one processor, it takes more time. So that one, this is a program available in the memory. and this will be distributed to some instruction distributed to processor 1, and some programs will be some instructions will be given to processor 2, and some instruction will be given to processor 3, and they will execute their programs and instructions simultaneously in multiprocessing parallel computing. It's called parallel computing. Parallel computing. In multiprocessing, parallel computing is achieved. There are more than one processor present in the system, which can execute more than one process at the same time. This will increase the throughput of the system. As I explained previously, instead of one processor, one ALU, there will be, if it is i5, i5 processor will be there. If it is i7, there will be 7 processors, and your program is same program that will be distributed. The instructions are distributed to different processors at the same time. Simultaneously, the instruction will go to in the processors. The process will execute the program, so throughput will be more. So time sharing systems. Time sharing means to share time in multiple slots in several processes. Time sharing system allowing multiple clients for the getting access to specific system resources at once from different remote locations, and it is the logically extension of the multi-program system. In this technique, time of single processor is shared in among multiple users over the entire network system simultaneously. While we discuss the processor, 7 processors are there. The memory is the program is in the memory. In time slots, they will distribute time sharing. That's time sharing means to share time into multiple slots in several processes. So time sharing system allowing multiple clients for getting access to specific system resource at once from different remote locations, and is logical extension of the multi-program system. So time sharing system, you are very familiar to multi-programming batch systems. In fact, time sharing systems are an extension of the multi-programming systems. In time sharing system, the prime focus is on minimizing the response time, while in multi-programming, the time focus is to maximize the CPU usage. So CPU is very costly one component in the computer, so you should maximum utilize the CPU. Time sharing system time sharing operating systems delivers direct access to multiple users while splitting CPU time among all users according to scheduled system, and the operating system assigns set of time for every user. When the time slots gets time out session, then it forwards own control to further user over the system. Time slots is getting very small, and all users are provided various impression which they contain own CPU as sole owner of CPU. This small time frame duration where all users grab attention of CPU, it is called the time slice or quant. So as we explained in the previous class, sessions, suppose these are jobs 1, 2, 3, 4 like this. So this is your processor. So once the processor, suppose it requires 2 milliseconds, it requires 4 milliseconds, and it requires 6 milliseconds like this for execution of each instruction. So what the OS will do, initially it will add 1 millisecond for this job 1. So it will stack this where it has completed the job, and it will stack there, and it will switch on to second one. After 1 millisecond, it will switch on to third one. Like this, it will keep on switching over to one job to another job. So after completion of the last instruction, again it come back to first instruction, and again it will execute for the 1 millisecond. So like this, that one time quantum is given. That is called time slicing. So for the OS will make sure that the CPU will execute first instruction for 1 millisecond, second instruction 1 millisecond, third one, fourth one, like this. After completion of the last instruction, it will come back to first instruction where it start the job where it left after first 1 millisecond. So it will work for 1 millisecond, and all it will complete in turn for all jobs 1 milliseconds, and like this, that time slice, that's called time quantum. For that particular time only, it will work with the instruction, and it will stack the left for a job, and it will go back to another instruction, another job, and it will work for 1 millisecond. After that, like this, it will time quantum will be there. That time sharing, the time slot is allotted for the CPU by the OS. So time sharing system. So if you look at this diagram, user 5 is active state where the user 1, user 2, user 3, and user are getting to wait. It remains under wait state. But user 6 is ready to position for execution, because here in this one, if you look at one, so this is just like this is your CPU. CPU is here, and CPU, there is just, you say this is a switch, and it first will start from here. It will continue its job on for 1 millisecond, and the switch automatically comes to second person, and it will work for the another 1 millisecond. Like this, the switch will keep on rotating till last man. Again, it will come back to the first man. So this is a time sharing systems, where you will find the internet operations. The clients will the client will log into 100 clients will log into one server. So everybody feels server is with me only. But by using this time sharing system, server keep on giving service to all the people. So time sharing system, active state, ready state, waiting state. Users program is getting to control of CPU, where one single program is present in this state. Ready state, users program is ready position for executing, but it is waiting for its turn to getting for its CPU. So waiting state, either users program is getting to wait for few operations, multiple users also cannot be waiting for position at once. This is nothing but, as we've seen earlier, this diagram. A time sharing system, requirement of the time sharing system, operating system. Time sharing operating system requires an alarm clock that helps to send an interrupt single for CPU after each time interval. CPU is working, CPU is always busy, is working, executing the jobs. So whenever it turns over, automatically it will stop it there and go to next job. So to remember, to alert the CPU, one alarm clock is required. This alarm clock will raise the signal to CPU stop that job and switch over to another job. So that is requires this alarm clock system that helps help to send an interrupt signal to CPU. So memory protection system helps to protect signals, job instructions, as well as interfacing all data with other jobs. So that is main requirement of the time sharing system, because our system is CPU is always busy. CPU only one CPU, this one CPU is there, but CPU has to switch off that one and switch over to another job of particular time, the time quantum. So that for that one we require one clock. So examples of time sharing operating system, for example, in transaction processing system, all types of processes have ability to execute every user program in small bursts. Small burst or quantum of computation. Like as when users are exist, then every user is capable of to grab in time quantum. So that how the job is completed. Okay. Time sharing systems, features of time sharing operating system. Each user grabs dedicated time for all operations. Multiple online users can use same computer at same time. End users may feel that they monopolize the computer system. Better interaction in between users and computers. Users' request can be made in small time to respond. It doesn't need longer to wait for a last task and it gets processed. It has the ability to make quick processing with a lot of tasks. So it is very simple. So there are suppose there are 100 jobs. 100 job is nothing but instruction. So 100 instruction nothing but a line in the program. So there are 100 in program is there. So each line, suppose first line is taking for execution, for a completed execution, suppose 5 milliseconds. So other second instruction has to wait for 5 milliseconds. No. In case of time sharing system, second instruction no need to wait for 5 milliseconds. The first, as for time quantum, the CPU will execute for first instruction for 1 millisecond, and later on it will switch over to second instruction, the second job after 1 millisecond. Like this, time quantum is set. That is time. That's called time sharing. So like this, it will keep on executing all instructions, all jobs till 100 job. Again, it will come back to first instruction where it is left, and it will continue from there itself. So this is called time sharing, and ultimately the complete program is executed by time sharing. So the waiting less time will be less. So 100 job which has to wait till the end of the first all instructions. So it takes a lot of time. So by using this time sharing system, waiting time will be decreased by the job for the jobs. So time sharing system advantages. Just if you look at the time sharing system advantages, it delivers quick response. Every task makes some same opportunity because task is nothing but a job. Easy to use and user friendly. It helps to increase performance of entire system. Multiple applications can be run at once. More efficient and convenient to use. It eliminates replication of software. It interactive computing, decrease paperwork. It decreases CPU idle time because idle time CPU is always busy because jobs keep CPU keep on switching over to one job to another job for a particular time. So CPU is always busy. So these are the main advantages of the time sharing systems. Disadvantage. This creates reliability use. It creates reliability use issue. Less security and integrity, data and user programs. Issue of data communication. It consumes much system response resources. Hangs a program, so it must have higher application hardware, specification hardware components because there are a lot of users and their other applications work at once. So after the same time sharing, you will see how the personal computer works, what are the parts, and what is this personal computer. The personal computer operating system provides a good interface to a single user because personal computer will be used by single user. So personal computer operating systems are widely used for word processing, spreadsheets, and internet access. Personal computer operating systems are made only for personal use. So we can say that your personal laptops, computer systems, tablets, or your personal computers and the operating systems such as Windows 10, Android, extra your personal computer operating systems. So we'll see what is this parallel distributed systems. While both distributed computing and parallel computing are widely available these days, the main difference between these two is that parallel computing system consists of multiple processors that communicate with each other used by shared memory. Whereas distributed system contains multiple processes connected by communication network. If you see this parallel computing, this in this I3, I5, or I7, there will be three processes, 1, 2, 3 processes will be there, and this is our program which is stored in the memory. And when it is working parallelly, some instructions, nothing but in the program, some lines will be transferred to processor 1 for execution, and some instructions will be sent to your processor 3 for execution. So they will execute the your program parallelly. This is parallel computing because only program is one, but all three systems are sharing your memory data where is shared in the memory, and it is shared by three processors, and they're running this program parallelly. They're executing this program parallelly. This is called parallel computing. Whereas distributed computing system contains multiple processes connected by a communication network. That is just good as our internet. Parallel distributed systems. Distributed operating system. These types of operating systems is a recent advancement in this world of computer technology and are being widely accepted all over the world, and that too with a great pace. So various autonomous interconnected computer communicate with each other using a shared communication network. independent system possess their own memory unit and CPU. These are referred as loosely coupled systems. Distributed operating systems. It's just this is a parallel distributed. We look at this diagram. If you look at this diagram, in this one, this is an independent system, and this is independent system. This is independent system, and this is independent system. This is independent system. All are independent systems. These are all independent system 1, 2, 3, 4, 5, and these systems are connected to the operating system. This is nothing but parallelly. The operating system will monitor all the systems at the same time. So parallel distributed systems. So we'll look at this one, this architecture of distributed OS. So in this one, memory, this is a system, this is another system, this is another system, this is another system. Systems are independent systems are there, and they will be connected through a communication network. They are connected in the communication network. So they will these systems will interface or interconnect with each other by using this communication network. This is called distributed OS. So advantage of distributed operating system. So in this case, if one failure of one system will not affect the other network communications, as all systems are independent from each other. So electronic will increases the data exchange speed. Since the resources are being shared, communication is highly fast and durable. Load on host computer reduces, and these systems are easily scalable, as many systems can be easily added to the network. Delay in data processing units. This is one of the disadvantages. And failure of main network will stop the entire communication. To establish distributed systems, the language which is used to are not well defined yet. These type of systems are not readily available, as they are very expensive. Not only the underlying software is highly complex and not understood yet. Example of distributed operating systems, locus and extra. So another one is network operating system. We were discussing about different types of operating system: batch system, multi-programming, parallel distributed. Another one is network operating system. So what operating system will use for different type of structure. So these systems run on a server and provide the capability to manage the data, users, groups, security. So if you look at this diagram, this is network operating system. So systems, this is client and server, client and server. So the clients will log into server, and there will be communication between the server to client. So if you look at this network operating, just look at this one. These systems run on a server and provide the capability to manage data, users, groups, security, applications, and other networking functions. This type of operating systems allow shared access of files, printers, security applications, and other networking functions over a small private network. One more important aspect of network operating systems is that all the users are well aware of the underlying configuration of all other users within the network, their individual connections, etc., and that have their individual connections, etc. And that's why these computers popularly known as tightly coupled systems. So the operating system running in this server client environment. So in the server always there will be one OS we call Linux. We are installing the server, and client may have any type of OS. But why Linux is installed in the server means the Linux will have the capability to handle the number of clients at the same time, because there are programs in the Linux which can handle number of clients at the same time. So same one client logged into a server. So we will have this server will be giving service to client one. So meantime, some client two also logged in. So in that case, whatever the OS in the server, that Linux OS Linux, in this one, multi-threading concepts are there, that it will create one Xerox copy Xerox copy of OS, the Linux, and hand over to handle the client 2. So like this, it will handle the clients one or one number like this, more than 2 clients at the same time. So this is network operating system. So network operating system advantages of network operating systems: highly stable, centralized servers. Security concerns are handled through servers. New technologies and hardware upgradation are easily integrated into the system. Server access is possible remotely from different locations and types of systems. And at the same time, we got some disadvantages of the network operating system. So disadvantages of network operating system are: servers are costly because everybody cannot hold the server. Users has to depend on a central location for most operations, because server has to give the service to the client. The maintenance and updates are required regularly. So examples of network operating systems are Microsoft Windows Server 203, Microsoft Windows Server 208, Unix, Linux, Mac OS 3, Novel Network. These are the network operating systems we use in the server: Linux, Unix, Mac OS X, and these are the operating systems. So we'll see what is real-time operating system, real-time systems. The real-time system means that system is subject to real-time. So I'll tell you one example. In this case, suppose our cell phone or our aircraft. So in aircraft also they use some softwares. These softwares are very accurate and time conscious. If that work should not be done in time, the aircraft will fall in the dangers, hazard. There will be some problem. So in the same type, suppose there is a furnace. If temperature is increasing a certain range, the furnace should be switched off by software. So if it is not possible, it could not be done in time, the complete furnace will blast. So that's what I want is the real-time operating system. Real-time operating system is accurate, time sensitive. If doesn't take action in time, then there will be a problem. So types of real-time operating system is time based on the time constraints: hard real-time system, soft real-time systems. So real-time operating systems, these types of OS are several severe real-time systems. They will serve in real-time operations. The time interval required to process and respond to inputs very small, very minute. If the action is not taken in time, there will be whole system will be blast. So that's why the time gap for the interaction is very small. This time interval is called response time. Response time. Real-time systems are used when there are time requirements that are very strict, like missile systems, aircraft control systems, robots. So application, RTOS, kernel, BSP. If you look at this diagram in the real-time systems, so application programs, real-time. This is called real-time OS. This is called real-time OS. This is real-time OS, and this is a hardware. If it doesn't respond in time, then your OS is not responded immediately to this application program. So whole system will be crashed. So two types of real-time operating systems: hard real-time systems. These OS are meant for application where these time constraints are very strict, and even the shortest possible delay is not acceptable. These systems are built for saving life, like automatic parachutes or airbags, which are required to be readily available in case of any accident. Virtual memory is rarely found. We don't use virtual. If it is on the spot, the action will be taken on the spot. If it's not taken on the spot, the system will collapse. So like this, real-time operating system. So So what is a soft real-time system? These OS are for applications where time constant is less strict. So it may take delay. The delay may be permitted. That is certain our systems or normal computer systems. If you switch on, it takes some time. Some delay is acceptable. So nothing will happen. So whereas our real time means there is no delay. Fraction of second delay also causes very worst damage. So that is that's one. So advantage of RTOS. Maximum consumption. Maximum utilization of devices and systems, thus more output from all resources. Task shifting. The time assigned for shifting tasks in these systems are very less. For example, in older systems, it takes about 10 milliseconds, 10 microseconds in shifting one task to another. And in the latest systems, it takes 3 microseconds. So time delay is decreased. Focus on application. Focus on running application and less importance application which are at in queue. The real-time operating systems in embedded systems. Since the size of the programs are small, RTOS can also be used to improve embedded systems like in transport and others. So error-free. These type of systems are error-free. If error is not at all permitted. If any error occurs, the complete system will go in worst. So complete system will get damaged. Memory allocation. Memory allocation is best managed in these types of systems because there is no delay to get to go to the memory and get the data because data is readily available to execute. That is readily available. Suppose there was some airbag in the car. If there is any delay when the accident occurs, if software is not working and code is not working to open your system, then there will be fatal damage for the driver and the car. So limited tasks, very few tasks done in the system's time, and their concentration is very less, and few applications to avoid errors. Use heavy systems resource. Some systems, sometimes the system resources are not so good, and they are expensive as well. Complex algorithms. The algorithms are very complex and difficult for the designers to write on. Device drivers and interrupt signals. It needs specific device drivers and interrupt signals to respond earliest to interrupts. Threat priority. It is not good set threat priority at these times are so very less. Time is very less. So we should not use switching tasks. So example of real-time operating systems are scientific experiments, medical emergency systems, industrial control systems, weapons system, robots, aircraft control systems like this. Special purpose systems. These are various classes of computer systems based upon their computational speed, uses, hardware. The following are some special purpose systems according to specific applications: real-time embedded systems, multimedia systems, and handheld and portable systems. So other system services we will discuss in the next session.
Like, share and subscribe. Hit the bell icon for more updates.